This day is very exam heavy because it mixes state, memory, tools, and tracing, all things that break silently if you design them wrong. AgentCore Strands Memory State. Big idea, one sentence. An agent is not a single prompt. It's a long-lived system with state, memory, tools, and traceability. 1. AgentCore versus Strands, conceptual, not syntax. You'll see different names, but AWS is testing the concept, not the brain AgentCore, conceptually. The runtime brain of the agent decides next action, calls tools, updates state, reads, writes memory. Think the control loop. Strands, independent execution threads or reasoning paths. One strand might be booking, another validating, another fetching context. Strands let agents do multi-step reasoning, pause and resume, branch safely. Exam mindset. You are not expected to code this, only to design for it. Number 2, agent state versus memory. This distinction matters. Agent state, short-term, current task, step number, tool call in progress, temporary variables. State is session scoped, mutable, short-lived. Example, user is halfway through booking an appointment. Agent memory, long-term, user preferences, past interactions, known entities, historical outcomes. Memory is persistent, durable, reused across sessions. Example, user prefers morning appointments. Exam trap state, memory. Mixing them is a design flaw. Number 3, where AWS expects you to store memory. The most common and exam-safe answer, Amazon DynamoDB. Why DynamoDB? Low latency, durable, key-based access, user ID, agent ID, scales cleanly typical keys, PK user ID, escates memory type, timestamp. If an answer stores long-term memory only in prompts. 4, AWS Static+1 Agent Memory Edition. Static, agent logic, tool definitions, memory schema, state machine rules. +1, current user interaction. The agent design stays fixed. Conversations change. That's static +1 again. Number 5, tool integration patterns, very exam-y. Agents don't do things. They call tools. Common tool patterns, Lambda functions, APIs, databases, search, RAG tools. Wrong design, tool logic embedded in prompts, no validation, no traceability. Exam signal external system, action, side effect, tool call. Number 6, why agent tracing exists. This is critical. Agents fail in non-obvious ways. Wrong tool order, repeated loops, hallucinated tool arguments, state corruption. Tracing answers, what did the agent think? Which tool did it call? In what order? With what input-output? Number 7, what agent tracing implies in AWS terms. Tracing means step-by-step visibility, tool calls logged, state transitions recorded, timestamps preserved, typically integrated with Amazon CloudWatch, AWS X-Ray, exam signal debug, audit, governance, explain behavior, tracing plus logs. 8, why tracing matters for governance, not just debugging. AWS cares about compliance, explainability, audit trails. Tracing lets you answer, why was this action taken? Which data was used? Which tool modified a record? Who approved this logic? If an exam question mentions regulated systems, tracing is mandatory. 9, realistic agent architecture, exam-friendly. You can see the code in our conversation history. This loop may run multiple times per request. 10, classic exam traps, watch carefully. Store agent memory only in prompts. No need to trace if responses look fine. State and memory are the same. Tools are just prompt instructions. AWS wants systems, not clever prompts. One memory story. The assistant with a notebook. State, what page they're currently on. Memory, notes saved in a filing cabinet. Tools, phone calls they can make. Tracing, CCTV footage of everything they did. If something goes wrong, you don't ask the assistant to remember better. You review the footage. Exam compression rules, memorize. Short-term state, long-term memory. DynamoDB, actions, tools, debug and audit, tracing, design once, static +1. If an answer treats an agent like a single prompt, wrong. What AWS is really testing, they want to know if you understand that agents are long-running, auditable systems, not chat completions. If your answer includes state, memory, tools, tracing, you're answering at AWS professional level. Here are 3 very real production-style examples that map exactly to what AWS expects you to design and reason about in the exam. Real examples. Day 13, AgentCore, memory, state, tools, and tracing. Example 1, AI receptionist for a dental clinic, classic agent plus memory. Scenario, an AI receptionist books appointments, answers questions, and follows up later. A user calls today, then again next week. What is state here? State is temporary and session bound. During one call, current steps, collect preferred date, missing info equals provider, tool in progress will check availability. This lives only for the session. If the call drops, state is discarded. What is memory here? Memory is long-term and reusable. Stored in Amazon DynamoDB, you can see the code in our conversation history. Next week, the agent reads memory, skips unnecessary questions, personalizes behavior. Exam takeaway. Open quote, state equals what's happening now, memory equals what we know forever, close quote. Tool integration. When booking, agent calls a booking API, Lambda tool, receives availability, updates state, writes confirmed appointment to memory. Tools are external actions, never prompt tricks. Example 2, compliance-sensitive agent, why tracing matters. Scenario, an agent assists staff with financial compliance checks. One day, it incorrectly approves a transaction. Now auditors ask, open quote, why did the agent do that? Close quote. Without tracing bad design, you only have final answer, no visibility. This fails governance requirements. With tracing, correct AWS design, the agent records reasoning steps, tool calls, inputs and outputs, timestamps. Stored via Amazon CloudWatch, logs, AWS X-Ray, execution path. You can now answer which rule was applied, which data source was queried, which tool approved the transaction. Exam signal. If you see audit, compliance, regulated, explain decision tracing is mandatory. Example 3, multi-step agent with Strands, branching safely. Scenario, an agent handles, open quote, book an appointment and send me a confirmation SMS, close quote. This is not one action. Hashed how strands appear conceptually. The agent creates separate strands, strand A, booking logic, strand B, notification logic. Each strand has its own state, can succeed or fail independently. If booking succeeds, SMS fails. The agent retries SMS, does not rebook the appointment. Exam takeaway. Strands prevent cascading failures in multi-step agents. Example 4, RAG-enabled agent with memory plus tools. Scenario, a policy assistant agent, answers questions, remembers what documents a user already reviewed. Flow 1, user asks a policy question. 2, agent checks memory for previously accessed topics, avoids repeating explanations. 3, agent calls, retrieval tool, OpenSearch KB. 4, agent responds. 5, memory updated, user reviewed policy X. Next question, agent retrieves only new context, response is shorter and more relevant. This improves UX, cost, accuracy. Example 5, debugging an agent loop, real failure mode. Problem, agent keeps calling the same tool repeatedly. Without tracing, you see, slow response, high cost, no idea why. With tracing, you see, state never transitions, tool result not validated, agent re-enters same step. Fix, update state transition logic, add guard condition. Exam signal, agent loops, unexpected behavior, tracing plus state inspection. Statics 1, real-world anchoring, static agent logic, tool definitions, memory schema, tracing configuration. Plus 1, current interaction, design once, run forever. 1 memory story, never forget. The assistant at a desk, state, sticky notes on the desk, memory filing cabinet, DynamoDB, tools, phone calls and emails, tracing CCTV footage. When something goes wrong, you check the footage, not guess. Ultra short exam cheat sheet, long-term info, DynamoDB, short-term flow, state, external actions, tools, debug and audit, tracing, agents, co-prompts. If an answer treats agents as just prompts,